Miss Connolly. I started making videos for my 5th grade students and then decided that I wanted all students to benefit during this crazy time with math instruction. So I'm making videos for as many grades as possible, 1st through 5th grade. So if you need a topic covered, please email me connollymathathome@gmail.com. I'm making a series of videos right now about comparing fractions. So this is one video out of several comparing fractions videos. So make sure you check out the other ones. I just completed comparing fractions with the same denominator, which is introduced in 3rd grade, revisited in 4th grade, and super important when we get to 5th grade. So all of these things all come together, which is great about math. So make sure you check out those videos. All right, so last video was about the same denominator, how to compare fractions when the denominator is the same. Today, we're going to talk about when the numerator is the same. Okay, so the numerator is the top number in a fraction, so I'll point that out in a second. So we're going to think about when the numerator is the same. When we're talking about a fraction like 2/3 and 2/6, the numerator up here is the same, but the denominator is different. So we're going to be thinking about what happens when we have two fractions that have the same numerator but different denominators. One of my favorite things. So by the end, we're going to form what I call a conjecture. That's an opinion that we're going to form about how to compare these fractions, even though we can't explore every possible time that numerators are the same. We're going to come up with a rule that we think would work every time we compare two fractions with the same numerator. So let's get started. Two ways that you can compare fractions in the 3rd grade is you are thinking about the area model representation. And I want to point out to you what I pointed out in the last video. When we are comparing fractions, you have to draw the same size whole to start. Okay, we're always comparing fractions with the same size whole. So when I'm doing the area model, I like to put them right on top of each other so I know that my width is the same, and then I try to use my eyes to just see that I made the same size length. Okay, so the first one I'm going to represent is 2/3. So what I'm going to do is I'm going to draw thirds, try to make the equal sized pieces as much as I can. So I made 1, 2, 3 equal sized pieces, and I'm going to shade in 2 of them. Okay, I want you thinking about the size of the pieces when we're comparing every single time. Okay, next I'm going to draw 6. And my numerator is the same, so I'm going to shade in 2. So after we've represented 2/3 and 2/6, I'm wondering which one that you think is greater. From our area model representation, you can see clearly that 2/3 is more of the whole than 2/6 is. Okay, and I'm wondering if you're thinking about why. I colored in the same number of pieces. I colored in 2 here and 2 here. So you should be thinking about, why is this happening? Why is 2/3 greater than 2/6? Okay, so that's on the area model. Another way that we represent is on the number line, 0 to 1. If our fractions are between 0 and 1, then we would use 0 to 1. And so on one number line, I'm going to represent 2/3, and on another one, I'm going to represent 2/6. Just so you know, you can compare on the same number line. Sometimes I think it gets a little complicated, up to you, but I'm going to do it this way. I line them up perfectly, just like I did with the area model. That's how I know I made the same size whole. So 1/3, 2/3, it's a little off, I'm going to move her over just right here. 2/3, and then in one of my videos about representing on the number line, 3/3 is the same as 1 whole, if I added 1 more third. And then I'm going to do 6ths on this number line. 1, 2, 3, 4. Yeah, this is not correct. Something is off here. Hold on. 2/3 should be here. All right, so we have 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. Sorry, I was trying to make my pieces as equal size as possible. A little bit difficult sometimes, but you're always going to try your best. All right, so 2/3 falls here on the number line. This is the distance from 0 to 2/3, and 2/6 falls here on the number line. That's a distance from 0 to 2/6. Clearly, we can see that 2/3 is a further distance from 0, and 2/6 is not as far from 0. And I'm wondering if you're still noticing something about the pieces. So we have this, those pieces, and then we have these pieces. I still counted 2, 1, 2. I still counted 2 pieces, 1, 2. But 2/3 is greater. Okay, so I'm going to write up here. So we're going to make a little collection. 2/3 is greater than 2/6. I went over this. My alligator teeth are always chewing on the larger fraction. Those are alligator teeth in case you couldn't tell what was going on. Okay, so that is one example when the numerators are the same. Let's do another when the numerators are the same. Okay, let's think about when we have 3/4 and when we have 3/6. Okay, so we're going to compare 3/4 to 3/6. So again, same size hole on my area model. Are you making a prediction? I hope you're making a prediction. Which one is going to be greater, do you think? Interesting. I'm wondering myself. So let's do 3/4 best we can, and I'm going to shade in 3 of these pieces. And then let's do 3/6. And then we're going to shade in 3 of those pieces. So again, this is 3/4, this is 3/6. It's so weird because I'm shading in 3 pieces, but one of them is larger. It's this one. You can see it from the picture, right? So 3/4 is greater than 3/6. So weird. Why? Think about the size of the pieces, okay? Because we're going to get there. So let's do it on the number line. Make sure we got it. The number line is our other representation we're going to rely on when we're comparing. Again, we are partitioning the number line into 4 equal pieces and then into 6 equal pieces the best that we can. I'm trying to do it kind of quick so the video doesn't end up being too long. Okay, I'm going to I put a mark there on 3/4, going to put a mark here on 3/6, and which one has a greater distance from 0? We can tell that 3/4 again is larger, and I really want you to look at this piece compared to this piece, and this piece compared to this piece. What's going on? Why is 3/4 larger than 3/6? I want you to think about the size of the pieces. You heard me say that? So over here, I'm going to write it down again. 3/4 is greater than 3/6. And we'll do one more. This time I'm going to do, let's think about 1/4 and 1/2. I wonder if you already know which one might be greater. So, area model, same size holes, the best that we can. Because if I eat half of a large pizza and you eat half of a small pizza, we can't compare them. They have to be the same size holes. So let's think about 1/4 and let's think about 1/2. So that one's 1/4, this one's 1/2. I only colored in one piece of both of them, but one of them is clearly larger, right? 1/2 is greater than 1/4. We can see it in the representation. Let's do a number line really fast. 1/4, 2/4, 3/4, 4/4. And what do you predict? Do you think that 1/2 is greater? So what's going on? What is happening here? I'm still coloring in one piece of each. I did 1/4, I did 1/2, and we can clearly see that 1/2 is greater than 1/4. what's happening? Well, friends, I'm hoping that you're already coming up with what we call a conjecture, an opinion. But what happens with the size of the pieces when our denominator gets bigger? Okay, so let's just think about 1/2 right now. I'm going to show you again 1/4. Now while you're thinking, what's happening to the size of the pieces as my denominator gets greater? So my denominator got greater. My pieces, the size of my pieces got smaller. So if you're thinking about sharing this pizza with just between 2 people, you get a bigger piece, right? But then your little sister and brother come along, always ruining the party, and you have to share with more people, you get less pizza. Then let's say some more friends come over, and now our denominator is going to get larger again. I'm going to make 1/8. Our pieces get even smaller. Okay, so as your denominator gets bigger, so this denominator is getting bigger, your pieces are getting smaller. Okay, we see it here, 1/2. 1/4, the denominator gets larger, the pieces get smaller. 1/8, the denominator gets larger, the pieces get smaller, a lot smaller, right? So, when we have 2 fractions with the same numerator, so let's start writing it out, and you see if you can complete the sentence while I'm writing. When 2 fractions have the same numerator. So this is what happened each time here. I gave you the same numerator over and over. So when 2 fractions have the same numerator, the fraction with the smaller denominator, this is weird, it's going to feel weird, is greater. It feels weird, I know. When 2 fractions have the same numerator, 2/3 and 2/6, the fraction with the smaller denominator is greater. 2/3, the denominator is smaller, then 6. This one is greater because thirds are bigger pieces. Okay? It feels weird because things feel opposite right now. Okay? Again, when 2 fractions have the same numerator, the fraction with the smaller denominator is greater. 4 is a smaller denominator. It's greater than 6, or 3/4 is greater than 3/6 because these pieces are bigger. The smaller denominator gives you bigger pieces. If you're sharing with less people, you get more. Okay? We see it really clearly down here. When 2 fractions have the same numerator, the fraction with the smaller denominator is greater. Okay? So halves are bigger pieces than fourths. So 1/2 is greater than 1/4. And let's just make sure our conjecture is going to work every single time. Okay, so I'm going to give you 2 more examples and we'll make sure it works. So, fractions with the same numerator. I'm just going to stick with 1/6 versus 1/2. Okay, they both have a numerator of 1. So I look at the denominator and I say, which one has the smaller denominator? This one does, 1/2. This is going to be greater. I'm going to add to this because the pieces are bigger. That's why the smaller denominator is a greater fraction. So what does that mean? And that didn't work. Okay, so here's 1/6 and here's 1/2. So the fraction with the smaller denominator is bigger because the pieces are greater. And we can see that clearly here, right? So, not to brag, but I just proved it again. Let's look at one more example. I'll do it on the, no, I won't do it in the number line because of space, but let's think about 3/5 and 3/8. Okay, so let's get a area model. The numerator is the same. You should be predicting which one has the bigger pieces, because that's the one that's going to be larger when the numerators are the same. Only when the numerators are the same. Don't try to do this with other comparisons. Conjecture only works when the numerators are the same. So I say which one has the smaller denominator? Fifths, because, and it's greater because fifths are bigger pieces. So let's represent 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 3/5 is clearly greater than 3/8. And I know that even if I didn't draw the representation, because when two fractions have the same numerator, the fraction with the smaller denominator is greater because the pieces are bigger. So this one feels a little backwards because we're thinking about a smaller denominator, gives us bigger pieces, which means the fraction is greater. Only when the numerators are the same though, okay? So what did we learn here? We learned a brand new conjecture about comparing when two fractions have the same numerator. I also reviewed from the last video that we have to start with the same size wholes when we're talking about the area model, and the number line when we're comparing fractions, okay? In the last video I suggested to get a notebook, write down the conjectures, so hit pause, write it down, because you want to keep track of these and you want to start applying them each and every time you compare fractions. There is a lot of conjectures, and you're going to see why they're important, because when you get to the older grades, 4th and 5th, we start comparing fractions that are so close in size that you can't tell all the time from a representation that we draw ourselves. Okay, so practice using the conjectures, practice making the same size area models, same size number line, same size whole, and comparing fractions. Okay, and make sure you watch the other videos so you can learn more conjecture.